And today we are going to be talking about OWASP dependency track. So again, real quick about me, and then we'll get to the actual meat of the conversation. But I'm the creator and the current lead of the dependency track project. I'm also the co-lead as well as the chair of the Cyclone DX core working group, co-leader and co-author of the OWASP SCVS project. And I do just a tremendous amount of work, I guess, in the software transparency space and in supply chain space. But what I actually get paid to do is software security architecture at a leadership level at ServiceNow. So real quick background, I guess. Dependency Track is a flagship OWASP project. It was started in 2013. It is highly mature. There's a really big community of adopters that use it. If you name a commercial vendor or organization, they're probably on the list of people who have either tried it or are using it today. As of now, I think we've got about 4 million Docker pulls to date, so it's fairly strong, and it's Apache 2.0 licensed. So Dependency Track is really centered around this concept of software bill of materials. And me and Patrick Dwyer will be doing a separate talk for OWASP Cyclone DX in about 90 minutes, which is yet another flagship OWASP project. But that particular project is specifically designed to be a software bill of materials standard. And Dependency Track is kind of based around this whole idea of software bill of materials. So real quick, what is a software bill of material? Well, an analogy would be the list of ingredients on the back of a food label, right? On the back of an energy bar, which is what this is, I have a list of ingredients. And by providing the list of ingredients, I, as a potential consumer, can make risk-based decisions. For example, if I am allergic to nuts, for example, well, this tells me that this ingredients list tells me that I have peanuts. And as a potential, allergy to that, that allows me to determine whether or not I want to take that risk or not. Well, in the software world, the analogy kind of transfers to something like this, right? I, as an organization, might have an allergic reaction to Apache struts. It's a really easy project to pick on just because there's been so many different types of the same classes of vulnerabilities. But it's along those lines, right? So if I have a list of prohibited components that I just don't want in my environment, a list of projects, for example, that maintain those, or just want to identify if a particular component has known vulnerabilities, this analogy allows me to do those types of use cases. So Dependency Track is really, again, it's centered around the concept of software bill of materials. Again, Patrick Dwyer and I, in 90 minutes from now, are going to be doing a talk on Cyclone DX, which is another flagship OWASP project. It's the leading software bill of material standard. It's interesting in that it is it's basically a standard that took individuals and vendors that were experts in the security space or in the security space, creating a bill of materials standard for software security use cases, and of course backed and whatnot by the leading security foundation, which is OWASP. So huge amount of credibility there. And I highly encourage everyone who's interested in the subject to also catch the other talk 90 minutes from now. So what exactly does Dependency Track do? Well, it consumes, analyzes, and produces SBOMs at high velocity. Okay, what does that mean? Well, it's ideal for use in modern build pipelines. So whether or not you are doing continuous integration, continuous delivery, that sort of thing, it's ideal for these types of use cases. It's also ideal for procurement and M&A cases. If I am procuring software from maybe a vendor, or if I am trying to maybe investigate if I wanted to acquire a company, SBOMs are a really good use for those types of use cases. And Dependency Track, although it's optimized for highly automated environments, It does support manual use cases, so you can get SBOMs from your vendors, from your organizations that you might want to acquire, and ingest those SBOMs and analyze those manually as well. And it's really designed, Dependency Track is really designed to answer the question, what is affected? And if so, where? So imagine I have 10,000 assets in my environment, and a shiny new vulnerability with a brand new logo comes up, and I want to know if I'm affected by that thing or not. If I have SBOMs for all of my assets, I can very quickly identify which assets in my environment actually have that particular component, that vulnerable component. So then I can, maybe proactively put in mitigations in place, maybe WAFs, or maybe I just have to pull the plug for that particular, asset until it can get patched. Whatever the case is, at least I can quickly identify what that thing is. So conceptually, I have an asset. It could be a microservice. It could be a monolithic application. It could be an IoT toaster or or a camera. It doesn't really matter what it is, but I have an asset, and I have a bill of material that describes the software stack and potentially the hardware for that particular asset. And then conceptually, I would analyze it. So that's the 30,000 foot view. Coming down a few thousand feet though, and let's look at a typical workflow. So the first thing that I want to do is actually create or acquire the SBOM. And creating SBOMs is fairly elementary. There's 80 plus tools in the CycloneDX Tool Center that allows you to do it. It's not hard. And of course, you can acquire those from vendors as well. Regardless of how you get one, that's the first step. The next step is to consume it into Dependency Track. So you ingest it into Dependency Track either through automation, whether or not it's in your CI/CD pipeline, or you can manually upload it in the user interface if you so choose. But the goal is to get it into the Dependency Track. And then Dependency Track from there on is going to analyze the contents of that software bill of material. So it's going to break down all the list of components, right? And start analyzing all of the list of components. It's going to analyze them for security risk. It's going to analyze them for operational risk, maybe things that are too old, for example. And it's also going to analyze them for license risk. So if you've got license policies created, that sort of thing, it'll analyze it for that type of risk as well. And it's going to do this on a continuous basis. So even after you've uploaded your software bill of material, at a minimum, that project that you uploaded it to is going to be analyzed every 24 hours. So if I have a asset in my environment that I got a bill of material from a year ago, it's still that inventory for that asset is still going to be continuously analyzed every 24 hours. And guess what? If a new vulnerability comes up, whatever the case is, I'm going to get notified of that in my environment. So keeping the information about what's potentially wrong with these assets isn't very useful. I need to create some streams so that I can create actionable things based on the intelligence that Dependency Track is providing. So there's a lot of finding information that Dependency Track provides with these streams. Everything to know everything about the vulnerability, for example, what assets, what things that are affected by that, obviously the severity and that sort of thing as well, so that you have enough information to make real-time risk-based decisions. So if I wanted to page my operations team at 2 o'clock in the morning, that might be one of the things that I do. Or maybe I automatically create a JIRA ticket, right? Whatever the case is. These are things that you can potentially do. And we also integrate with various types of chat ops in those types of things as well. So we can integrate with Slack, Microsoft Teams. You can create your own if you so choose. Email is still a thing, I guess. So you can do that as well. But the idea here is to get the data in and out of Dependency Track as efficiently as possible so that organizations can make better risk-based decisions. So with that, let's actually take a little bit of a demo of what Dependency Track does and kind of how it does it. So let me share my other window here. And that's going to be, let's see this browser right here. Let me go back to the dashboard here. So when you first log into Dependency Track, this is kind of what you're going to see is your dashboard. So at the top here, you've got a lot of time series metrics for the number of vulnerabilities that exist in my project portfolio, which is basically the aggregate of all things that I'm tracking. All the different projects that are potentially at risk, the number of components in my environment that I'm tracking, and some risk scores. It's basically a weighted severity score is essentially what it is. But again, there's a bunch of time series metrics here. We're really true believers in time series because we really want to know, are we doing better or worse over a given period of time? Maybe it's over a given release or a given quarter, whatever the case is, not only for the portfolio as a whole, but on a per project basis, right? So if I'm tracking a new development of something, I can track how well are we doing in that particular project over time. Like I said, everything is kind of a project. So a project could be an application, a microservice, could be that IoT toaster that I threw out there earlier. A project is just a container of some sorts, and in fact, it could be a container as well. Here I've got a couple different projects identified, and we'll go through a few of these to kind of show you what they are. In fact, I'm gonna choose WebGoat just because it's an OWASP project. And again, you'll see the time series metrics. Is it doing better or worse over time? Looks like it's about the same. You'll see any policy violations if there are any. I don't think I've actually set up any policy criteria in this particular case. The number of components you can see. So if I'm increasing the number of components, I can actually see that because it might be important to me. One of the Deming principles, who was a supply chain, among other things, guru, is really about using the fewer and better suppliers. So do I really want to increase the number of components in my project unnecessarily? Probably not. But this allows me some visualizations on, am I doing that or not? Because every component obviously introduces potential risk. But going into some of these tabs here, this is basically the list of ingredients, right? This is the contents of my SBOM right here. So this tells me I have 136 components, and it's going to tell me the name of those components, the version. This little arrow thing over here is going to tell me whether or not it's out of date or not. And this little warning says that this particular component is out of date. The little green one just says it's the current version. The group, if one exists, not all ecosystems have the concept of a group. But we all kind of have the concept of internal components, and internal components are these first-party components that we as an organization might actually create. So we can separate out the third-party from the first-party components. If the license could be identified or not, it's going to be here. And then, of course, if there's any known vulnerabilities in here or not. You can also, so you can go into like the component itself, for example. This is like looking at Bootstrap 337, and I can see over here that there's a number of vulnerabilities identified. But let's go back to the project here. And I want to show you the dependency graph, because when you import the software bill of material, yes, it's a list of ingredients, which is great. But how did the list of ingredients actually get there? Well, the dependency graph actually tells me how it got there. So this is my direct dependencies, for example, and then going on from there, these are kind of my transitive dependencies, and it keeps on going. It keeps on going from there. So this is one visualization that exists today in the dependency graph. There's more visualizations coming in the future. But not every third-party component, even if it's vulnerable, it may not necessarily be impacted by the application, right? Your application may not necessarily be impacted by a vulnerable component. Just because something is vulnerable doesn't mean your application is automatically going to be vulnerable. Sometimes it may, but in many cases, it will not. So we typically have to take a risk-based approach and actually look at some of these findings. So this allows us to do that. So if I wanted to look at this critical Jackson data bind issue here, I can see that I have a description of what the problem is. And like a lot of static analysis, like a lot of static analysis tools, I can actually make a comment as well as an audit decision about, am I exploitable to this thing or not? So maybe I am exploitable, or maybe it's a false positive, or maybe, and this is going to be a lot of the case sometimes, maybe I'm just not affected by this particular vulnerability, right? And I can make a comment about why I'm not affected by this thing, and it becomes part of my comment trail, my immutable audit trail. And then, of course, I can suppress it. And when I suppress it, my metrics will be reflective of that, because at this point, this particular vulnerability, I'm no longer impacted by that. So it's not a risk to this particular application. So you have the complete auditability in there as well. Let's actually choose a different project though. Let's actually choose this test project, because I threw out the concept of an IoT toaster just because it's funny. And this is a test project. It has one component. Not very exciting. But you know what? This component right here, it doesn't really do anything. It's a Java client that fetches stock quotes. Well, you typically have to reach out to the internet to be able to retrieve what the stock quotes are, right? I don't know about you, but I can't remember the last time that I actually used a standalone piece of software that didn't have a self-update, that didn't phone home to the internet to do something, right? So with Cyclone DX and with Dependency Track, we actually treat the entire stack, not just the actual software components themselves. So in this case, it actually depends on a service. Again, this was part of my software bill of material. And I can go into my service here and actually see, what the service is, who the provider is, what were the endpoints that this application is fetching, and maybe even some of the data classifications, as well as the directional flow of data. There's enough information in here for me to program, to create a threat model, a data flow diagram using threat models, which is really, really interesting. But again, let me go back to one of the core concepts of Dependency Track, which was, am I affected and where? So let's find out where Jackson Data Bind is at. So if I do a search for Jackson Data Bind, I'm going to see that in my environment, I have 3 different projects that actually use Jackson Data Bind. There's this project right here, WebGoat, and Drop Wizard. So think of a typical enterprise with tens of thousands of assets. Really, really quickly here, I was able to figure out which assets in my environment are potentially impacted by this particular vulnerable component. Now, I can also search for other things. I can search for package URL. I can search for CPEs. I can search for it by SWID tag IDs, which is useful for commercial software. And I can also search for it by hash. So, for example, if I know that I'm using a component, but maybe there's a malicious variant of that same component floating around on the internet somewhere, I can actually search for things by hash, which is also a really interesting use case. The other way to come to it, though, is through this way. And actually, let me just find a vulnerability real quick. We were looking at Jackson Data Bind, yes. So let me just pull this vulnerability right here, because you can also come to it from the other way. So imagine that a shiny new a new vulnerability comes up, gains a lot of press, has a logo, has its own website, and I want to know if I have any projects in my portfolio that are impacted by that thing. So I do a search for that vulnerability. I go into the vulnerability, and I have automatically here a list of affected projects. So right here, I search for a vulnerability that's making a lot of press. And right here, Dependency Track is telling me which projects are affected by that. So that's immensely powerful. So let's see, we've got 5-6 minutes left. We also support, security isn't the only use case. It's the one that that gaining the most. It's the one use case that has board level room discussions constantly. But license, intellectual property, and some other use cases are also important. Dependency Track handles those with as well. So we support all SPDX license identifiers. And we also support a policy engine that you can create different types of policies. So you can create license policies, you can create prohibited component policies, or that sort of thing. So there's a number of different types of policies that you can create that's also available to you. Let me go ahead and stop this share and go back to my deck here. So isn't essentially what we're talking about SCA? Kinda, but yeah, no, not really. SCA is really about looking at a specific application with a very specific type of lens. What SBOMs do is not only the transparency of that, but it looks at it with a completely different lens in a much broader lens. So it's definitely not SCA, although what you've seen here does have some SCA-like qualities, right? Known vulnerabilities, license compliance, outdated components. These are all use cases that most SCA products have today, but we did it not using SCA. We did it using software bill of materials. So software bill of materials are going to give you inventory use cases, which surprisingly is very, very difficult, and especially for SCA products to get it right. Much more easier to get it right with software bill of materials. But we can think of not only the components themselves, but what components include other components? Maybe in the Java world, for example, we have these things called shaded jars, where a jar might actually have 10 other products and 10 other components in there. That's really an assembly within CycloneDX, and Dependency Track supports that. We can tell where we got a component from. So whether it's a country of origin, whether it's a repository that we retrieved it from, that sort of provenance use case is what we're also targeting. We can target pedigree, and this is a future use case that we're going to be working on, where open source is the ultimate supply chain, and we are going to modify components and change them and rename them, and we can track all these modifications across our supply chain. That's pedigree. Ultimately, these things are packaged and distributed somewhere. Sometimes we put them in the cloud for production. Sometimes they're downloaded from customers on the internet. But packaging and distribution are cases. Remediation and disclosure are also other use cases. And of course, we also support hardware, because this is a full stack solution. We're not just looking at an application. We're literally looking at the full stack. And that full stack does include services. And in fact, like I said in the demo, we have enough information about services in the SBOM to actually programmatically create a data flow diagram that could be used for threat modeling, which is really, really interesting. So this in my mind is a really, really big win and a huge step forward into being able to make better risk-based decisions. We have a lot of integrations with Dependency Track. Obviously, the software bill of material format of choice is CycloneDX, but we're tool agnostic and we're vendor agnostic. So we support multiple sources of vulnerability intelligence, everything from the NVD to NPM advisories, VulnDB from risk-based security, of course, Sonatype OSS Index, and there's some other ones coming in the future as well. Support a number of different ecosystems and repositories. I mentioned Microsoft Teams and Slack. And of course, we have a bunch of different types of integrations, both native integrations like Defect Dojo and Fortify and Kenna, as well as some community integrations like from CodeDX and Security Compass and ThreadFix. So pretty big ecosystem, and it's being used in hundreds of thousands of organizations today. So a little bit about the project. This is the GitHub repo where you can find more information. We do have some social media accounts and a dedicated YouTube channel. I need to update the content on that. It's kind of lacking. Documentation is pretty good. And of course, there is our public website. So again, thank you, OWASP. Congratulations on 20 years. And I will see you in I'll be in the Slack channel. So catch me in the Slack channel for the next 30 minutes if you have any questions on Dependency Track. Cheers.